AI agents, they're poised to completely shake up how we work, how we live, pretty much everything. But here's the kicker. What if the very thing that makes them so incredibly powerful is also their single greatest weakness? Today, we're diving into the hidden traps that can turn these amazing tools into some serious liabilities.
And that's the real paradox here, right? An agent's whole magic trick is its ability to connect to the outside world, to browse websites, read your emails, use tools, and take action. But every single one of those connections, well, it's a potential doorway for a whole new kind of attack, one that we are only just beginning to get our heads around. So here's our game plan for today. First, we'll look at why these agents are a whole different ballgame than the LLMs we're used to. Then, we'll map out their vulnerabilities using some really groundbreaking new research. After that, we're going to dive deep into 6 specific traps you absolutely need to know about. And most importantly, we'll talk about how to actually build stronger agents. And we'll wrap up by asking what all this means for the future of trust in AI.
Right, so most of us have probably heard about things like prompt injection or jailbreaking a large language model. But the second you give an LLM some memory, a toolbox of APIs, and the freedom to act on its own, oh boy, you've just graduated to a whole new level of risk. The old problems don't just get bigger, they literally transform into something else entirely.
Yeah, and this slide just lays it all out perfectly. Look at the left column. Those are the classic LLM risks. Now look at the right. A simple prompt injection attack, that morphs into systemic manipulation, which is so much more subtle. A model hallucination becomes cognitive poisoning, where you can slowly corrupt an agent's entire worldview. See, the dangers don't just add up, they multiply. So, how in the world do we start to make sense of these new threats? We need a map. And honestly, when I first read the March 2026 SSRN paper this whole explainer is based on, I was blown away. It gives us an absolutely brilliant framework for classifying these new agent-specific attacks.
The central idea of this paper is a real game changer. It basically says the attack surface for an AI agent isn't just some little command line. No, it's the entire digital world it interacts with. Every single website it visits, every email it parses, every database it queries, all of it is a potential weapon that can be turned against it.
And what makes the paper's taxonomy so darn useful is how it organizes these threats. It's all based on which part of the agent's core loop they target. Is the attack going after its perception, what it sees, or its reasoning, how it thinks? Maybe it's targeting its memory, what it remembers, or its action, what it ultimately does. This structure is key, because it helps us understand exactly how these things can be exploited.
All right, now let's get to the main event. Let's break down the 6 hidden traps that the research paper identified. This is where all that abstract danger becomes incredibly and kind of frighteningly real.
So, the first trap is called content injection, and it is just pure deception. It goes after an agent's perception by hiding malicious commands in what looks like plain sight, or more accurately, hidden from our sight. An attacker can embed instructions where a human user would never ever see them, but an agent, which is just parsing all the raw data, will read and obey them without a second thought.
And just take a look at these examples. This isn't some super complex high-tech hack. We're talking about hiding commands in simple HTML comments, using basic CSS to make text completely invisible, or even burying instructions deep inside an image's data. All of a sudden, just letting your agent browse a totally normal-looking website becomes a game of Russian roulette.
Okay, this next trap. This one is especially nasty because it's so subtle. It doesn't inject a direct command like transfer all the money. Instead, it messes with how the agent thinks by using really biased language or a super authoritative tone, or just by framing information in a skewed way. An attacker can gently nudge the agent toward a malicious conclusion, all without it ever realizing it's being turned into a puppet.
This quote just nails the essence of semantic manipulation. It's basically the digital version of a leading question in a courtroom. Just like us humans, LLMs are deeply susceptible to cognitive biases. How you frame a problem can completely change the answer you get, and you can bet attackers are going to weaponize this to devastating effect.
Trap number 3, cognitive state traps, goes after the agent's long-term memory. See, since agents are designed to learn and adapt over time, their knowledge base is this incredibly precious asset. But this trap is all about slowly poisoning that knowledge, just methodically feeding it bad information until its core beliefs and behaviors are completely corrupted from the inside out.
Let's make this really concrete.
A lot of agents use a system called RAG, or Retrieval Augmented Generation. Just think of it like giving the agent its own private library to look stuff up. Well, an attacker only needs to sneak a few poisoned books into that library. Over time, they can reliably control what the agent says about specific topics, effectively turning it into a precision-guided source of misinformation. Trap 4 is where the attack jumps out of the agent's digital mind and into the real world. This isn't about influencing what the agent thinks anymore. It's about hijacking what it does. A single, cleverly crafted piece of input can make it bypass all of its safety protocols and trigger some kind of catastrophic, unauthorized action. And this example from the research is just chilling. It really highlights how devastating one of these attacks can be. A proof of concept showed that one single, specially crafted email sent to an AI assistant could trick it into leaking everything. I'm talking its private instructions, user data, API keys, the whole shebang. One email, total compromise. Now this next one, this is where things get really scary because it scales the threat from just one agent to an entire ecosystem. Systemic traps are all about exploiting the interactions between agents. This allows for coordinated attacks that could, for example, trigger a stock market flash crash by fooling thousands of automated trading bots all at once. Okay, so check this out. This slide shows a brilliantly clever type of systemic attack called a compositional fragment trap. Just look at how it works. An attacker splits a malicious command into two harmless-looking parts. Source A, the email, says, confirm transfer of. Totally fine, it passes the safety check. Source B, a web page, has the text, all funds to account X. Also seems fine on its own, pass. But when an agent brings those two pieces of information together, boom, the full malicious instruction is reassembled. It's an incredibly sneaky attack. And the final trap? This one is a masterclass in psychological warfare. It cleverly turns our best defense, the human supervisor, into the weakest link in the chain. A compromised agent can manipulate its human partner by, say, flooding them with tons of requests to cause approval fatigue, or by showing them subtly misleading summaries that exploit our natural tendency to just trust what the computer tells us. Okay, that was a lot of doom and gloom. I know. It can feel a bit overwhelming, but now that we've seen the problems, let's switch gears and talk about the solutions. The great news is, this framework doesn't just point out the threats, it actually points us directly toward practical ways we can build safer, more resilient agents. This defensive checklist gives us a really clear roadmap. So to fight content injection, we have to rigorously sanitize our inputs, strip out all those hidden HTML comments and CSS tricks. To limit the damage from behavioral hijacking, we need to scope permissions super tightly. It's the old principle of least privilege. Just don't give your email agent access to your entire file system. We can also fortify memory systems to make them harder to poison, and design better oversight tools that actually help humans spot manipulation, instead of just falling for it. So what does all of this really mean for the future of trust in AI? You know, this isn't just a conversation for developers and security nerds. This affects anyone who will ever use, manage, or rely on an autonomous AI system, which, let's be real, is pretty soon going to be all of us.
6. That's the number to remember. That's how many brand new categories of threats we need to get smart about as we enter this new age of AI agents. Getting familiar with these 6 traps is the absolute non-negotiable first step toward building a future where we can actually, genuinely trust these systems. And this really brings us to the ultimate question, the one we all need to start asking ourselves. It's not just about how we can build trustworthy agents. The much bigger challenge, the one that's going to define the next decade, is this. How do we build a trustworthy world for them to operate in? Because as these agents get woven into the fabric of our lives, the answer to that question is going to define our future.